Hey, and welcome back. So, now things are starting to get more and more advanced. And we saw last time that you have to start making things work together, like the joystick controls affecting the sprites and so on. And we're gonna see more of that going forward. So from now on, we will not be looking at random test games that I make along the way, but from now on we're actually going to take a look at the finished game, which means that there might be some code here and there that we haven't gotten to yet. So hopefully this won't be confusing, but I think it's the best way now to see how things connect. So today's episode is going to be about something I call character collision, char collision. So I've started by showing you a drawing here that I made a few years ago. This was actually a drawing that I made when I was planning how to do character collision for my game. And as we can see here, I don't know if you can see it very well, but I've divided it into different sections here. So the point here is that the sprite is much bigger than just a normal character. A normal character is 8 by 8 pixels. It's just a little square with 8 by 8 pixels. Now a sprite is 24 pixels wide, 21 pixels tall. So it's much bigger than a character. So the point here is that if we go to my char pad, last time we saw our sprite moving around here. So the point here is that we need to say that our sprite is going to collide with certain things in here. So last time it was just like a ghost moving all across the screen, no collision or anything like that. Now let's imagine this little arrow is the sprite. Now we need to make sure that when this little sprite collides with a wall, for example, then we want him to stop. Because if not, then this is going to be a little strange. So we want him to stop when he collides with a wall to the left. We want him to stop if he collides with a wall to the right. And if let's imagine we have gravity now, so he's moving down, then we also want him to stop when he falls down on something like that. And also if he jumps and collides with a tile like that. But we only want them to collide with certain of these tiles, these characters. So which means we can't have the same collision for this wall and floor over here as we have for these brown tiles. So that wouldn't make any sense, because if we stopped him for all of these, then he couldn't move at all, right? So we need to make sure that he can move freely when he's moving across this brown background. But when he reaches one of these characters, then he's going to stop. And for these I want to be special. I want him to stop if he falls on top of it like that. But I want him to be able to jump through it from the bottom. So a jump through platform of sorts. So jump through from the bottom and be able to land on the top. So different types of collisions based on what that character is. Now we're very lucky with the Commodore 64 because this is the way that screen RAM is set up makes it actually quite easy. First of all, these are different characters. So even though we have made tiles like this, we're going to use characters for collision. So for example, this tile is made up of 4 character number 67 here. So we also know that we can read screen RAM. So we know what characters are here, here, all over here. So we need to make a system that will read where the player is and if he's colliding with a character. Now the problem about that is the following. Remember how the screen is set up on the Commodore 64. We have 40 columns across, we have 25 rows down. So we have these little cells with 8 by 8 pixels, right? These are the character cells. We know this. But what about the sprite? Well, this is a little guy who is 24 pixels wide, 21 pixels tall. This guy moves smoothly across the screen, 1 pixel at a time, if that's what we want. But let's say we move him 1 pixel at a time. That's no problem. Up or down, left or right, no problem moving a sprite like that on the Commodore 64. So, what am I getting at? Well, there might be a little mismatch between this guy and these character blocks, these character cells, because they operate at an 8 by 8 grid system. So for example, this is row 0. If we go 1 row down, this is row 1, 1 row down, this is row 2, and so on. So let's imagine that we're talking pixels now instead of rows. So we start, the top row here starts at 0, the top here. Then what about this next row? Well, that's 8 pixels down, so that would be 8 pixels. Next one, it would be 8 more pixels, so 16 pixels down. And next one, 24 pixels down, and so on. So we're moving 8 pixels down for every row we go down. Same thing if you look at columns. This column is 8 pixels. So if we go 1 column to the right, then that column starts at 8 pixels from the left. And this starts from 16 pixels. This column is 16 pixels from left to right. So column, yeah. I've written 1, 2, 3 here. I should have written from 0, but whatever. The point here is that these are not a one-to-one match of the sprite's position, because the sprite might be at pixel position, let's say 4 pixels from the top. Well, if he's 4 pixels from the top, is he on the first row, in the second row? How's that going to work? So we may need to make a system for that. And now we also need to think about something else. Let's look at how big he is. He basically covers 1, 2, 3 columns. He covers 3 full columns. 8, 16, 24. And that's exactly how wide our sprite is. And then we have we have 8, 16, 24. Our sprite is 21 pixels tall. So almost 3 rows as well. So basically he covers 9 cells like this. That gives us another challenge. If he's moving around like this and he gets down here, so let's say that this is a platform. This yellow thing is something that I'm going to collide with. So if I'm here, for example, and now I want to move to the right, well, where should I check collision now? Alright, maybe you can say the top right corner of the sprite. Alright, what about now? Where should I check collision now? How about now? You know, so my point is that if we go back to my drawing, what I was trying to plan when I made this drawing a few years ago was that I actually need to check character collision for a sprite in several places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 points on the sprite is going to check for collision. Now, exactly how that works, we're going to look at that in just a minute. But first of all, we need to understand the concept that in order for this guy for this to make sense, right? He's much bigger than a character. So he covers several characters. So we need to have several checks. So I'm gonna do it. I'm gonna make a check now. If he's moving up, right? I don't need to check these positions there at the bottom if he's moving up. Same thing if it's moving left, I don't need to check collision on the right, for example. So we need to do those sort of things to make this as smooth as possible. We don't want to make our code slow, right? We want to make this kind of effective, right? Some smooth code. So that's actually what we need to do. We need to make some sort of collision that will check for different characters. So like I said in the beginning, we are going to be looking at the final code. So there is going to be more than what concerns this episode. And if you look here on the right, you can see the whole thing. So it's quite a lot of code. So it's a little beyond what this episode is going to cover. But hopefully this will work out. Because we know about this. We have seen the sprite moving routine. The sprite handler, that I called it. But sprite movement is just one of the sprite handling things. But anyway, that's what we're interested in right now. So we have seen this way that I could control speed, how fast the sprite moves. We looked at this last time with this timer trick. So if the timer has reached the actual speed, then we reset the timer and we do some actual movement. And we have looked at the direction thing and so on. But let's say the direction was up now. The sprite is moving up. Alright, here's something new. Now I have added something here. Check char collision. And some stuff here in parentheses. What's this stuff? Check char collision. Well, there's no JSR in front of it like that. There's no jump or anything. So this must be a macro. And we can see that we have parentheses here. So yeah, this is definitely a macro. So I'm using a macro here, check char collision, with some arguments. And I'm doing that 3 times. So when a sprite is moving up, I'm checking 3 collision points here. So if we just look at the arguments here, check char collision. I'm gonna look at a macro just a second. But the arguments here are sprite offset up left, sprite offset up. So basically what this thing does, it checks the top left of the sprite. Are we colliding with a character at the top left of the sprite? This next one checks the center, sprite offset up center. So this is going to check the if there is a character at the center of the sprite when we're moving up. And finally, the last one here, up right. So this one checks if there's a tile at the top right corner of the sprite. So that's how I do it for every direction. So what do I do? Well, we're gonna look at this, as I said, just a minute, but I run some sort of routine there, check the collision, and there's a variable called char collision, and whatever happens in that routine is going to store what collision it was in that variable. And then we get down here, load A with that variable. So whatever happened in that collision routine, it stored something in this variable. Then I compare. So I have a little system with different kinds of character types. So if a character is a solid, then I can't move through it. I can't move through it from any side. And this is, as you see, it's a constant. It has a hashtag in front of it. And this, of course, is a number. I think it's number 1. So I'm loading this variable, comparing it to the char solid. If it turns out that from the collision routine it stored a 1 in here, compare that to char solid number 1. Branch if equal. Well, then there was a solid collision going up. Solid collision up, so we branch if equal to that. Well, solid collision up, then that's here. So if there was a collision there, then I go down here. And here we can see I just clear sprite direction, so another macro. But let's not worry about that for now. So the point here is that you can see that I have some sort of routine to check a character collision, and in here I'm comparing it to a solid. Now we can have different types of collisions, like for example you can have a character that's maybe a little coin or a diamond or whatever, something you can pick up, and that character could just disappear when you collided with it. So there are different things like that, but solid is a little special because that's going to affect movement. If you are colliding with a solid here, then we don't want to continue the movement routine here in the sprite handler. So if you're colliding with, with a sprite, then in this case, if I was colliding with sprite moving up, then I clear sprite direction up, which basically means stop moving up. If it didn't do that, then, and this was a solid tile, some sort of bricks, and if we didn't do that, then we would just move straight through it, and this whole thing would be pointless, right? So the way I do it to stop the movement is, so I check the collision. What kind of collision? Was it a solid? Yeah. Alright, then stop moving up. Alright, so let's take a look at this macro. So if I go into my macros folder now, I think it was in sprite macros, right? Yeah, in my sprite macros, I have something called check char collision, and this macro takes 2 arguments, offset x and offset y, so that I can adjust where I want to check the collision. And if we take a look at what I had here in my sprite library, I have some ready-made constants that say where those are. So if we go back here, this, I don't know if you can see this little pink, these pink lines that I have drawn here, but those sort of represent where we want to check collision. So we are not actually checking all the way on at the edges, because that could give us some issues, but let's not get into that right now. The point is that we have some sort of offset. so that he can, for example, a sprite can move smoothly up across a wall, and he can of course walk smoothly across the floor. Alright, well, let's not go further into that. The point is that we are checking these 3 collisions, and we are starting by using this macro. But as you can see here in this macro, there's not a lot happening in this macro. I'm just loading these 2 offsets and storing them into 2 different variables. So that's basically all that's going on in my macro. So like I said before, when using macros, it's a good idea to make them as small as possible, because like in this case, I'm using that macro 3 times. So for every time I use it, that's basically the same as pasting in this. So it's just 5 lines of code, so I should be okay. But the last line here, jump to subroutine, char collision. Now here's a new library. There's a library only for character collision. And that's just, it just made sense to me to make it like that. So a library for character collision and a subroutine in there called check char collision. Alright, let's look at my char collision library. Char collision library. Here we go. And here's the subroutine check char collision. What does this thing do? Well, remember the problem that I was talking about here. We need some sort of system to find out is the sprite here on the top row, second row, or whatever, because he's moving a pixel at a time. These guys, these cells, they are 8 by 8 grids, so it doesn't really match up. But if we quickly take our calculator here right now, and let's say that our sprite is here, so he or maybe he's there, so he is now at pixel position, let's say 10 here. Alright, so if he's at pixel position 10, let's think about this. This grid, that's 8 by 8 pixels. What if I divide my pixel position of the player? What if I divide that by 8? Well, this is a programmer's calculator, so I'm not gonna get some decimal number now, which is the same thing for my Commodore 64. If I do, and I did, so we can't do division, but we can do bit shifting, right? So if I, for now, let's just think about this. If I divide my pixel position by 8, then I actually get the row number. Let me do this for real so we don't get confused here. So I need to start from 0. So let me do that here as well so we don't get confused by this. Alright, so now we start counting columns and rows from 0. So now you can see that the top of my sprite, he is at row 1. So his pixel position is 10, but by dividing that by 8, I actually get the row number. So that's interesting, because this could be a useful system for us. Let's double check that. Let's say that he's what's this? 35, 40 maybe. Let's see. 40, let's say he's 40 pixels down now. And I divide that by 8. Okay, I was just guessing what his pixel position. So I divided it by 8 and it says 5. So probably should have been there. But anyway, the point is that I have done this several times before and it works out really great. We need to divide the pixel position. So the position of the player, X position or Y position. Both of those, we need to divide those by 8. Then we get the row number and the column number. And that's exactly what we need. So if I go back to my code now, I say load A with sprite Y position. Remember this table that we looked at. Okay, so load A with that. And then clear carry, add with carry. So I'm going to add something. What am I adding? Well, I'm adding the value from a sprite offset Y, which was what I added here in my when I ran this macro, check char collision. Remember, we're starting here in our sprite library, sprite moving around. Now we're checking collision, starting with this macro, sprite offset up and up left. So what's in that macro? Well, we know that we're just passing through these offset values, and then we are running this subroutine in the char collision library. So now we have come as far as this. we are loading the Y position right now. We are adding the Y offset, and then logic shift right. So bit shifting to the right 1, 2, 3 times. So let's say that we had this the thing that we just looked at. The sprite position was at 40 pixels. What if we bit shift that 3 times to the right now? LSR, logic shift right. Alright, 1, 2, 3. You see, I get the same result now. I get 5. So when I bit shift oh, I'm sorry. So if I bit shift 3 times to the right now, then I'm dividing by 8. Now if I continue my code now, I've just divided the Y position plus the offset. So I divided that by 8, which means that now, including my offset value, whatever that was, so including that, I just found my row number. That's interesting, because with my row number, now I can do something that we have seen before. Here I'm making sure to store my X register at a safe place. In this case, the temp X was a safe place. So I'm storing X in there temporarily and I'm loading it back here. Why I'm doing that? Well, because when I loaded in A up here and bit shifted around, I'm going to transfer A to X. I'm going to transfer that into X now. Because now I'm going to say load A with row low comma X. This we have seen before. So by loading something into X, the X register, and then loading from our tables here, then storing it into our 0-page variables, that's going to give us a memory address, a starting address from on the left side for any of the rows on our screen. So we've seen this before when we were making tiles. So that's what I'm doing, but this time I'm using the position, in this case the Y position of the sprite. The pixel position, but I added an offset, and we don't need to add an offset, but this is the finished game and I did it because that's going to give me a more smooth experience. But anyway, dividing that by 8, the pixel position of the sprite, dividing that by 8, transferring that, the result of what came from that, So for example, like we saw here, 40 pixels, 1, 2, 3, 40 pixels, that's row number 5. So, and I'm doing that, transferring to X, loading from those low and high byte tables, storing it to 0 page. So now we should be able to create an address, but that was the Y position on my player. So now I have the rows. I also need to know what column he's at. So I do the same thing, but this time for his X position of the player. And now I say I add the X offset here as well. But I also do the same thing. LSR. Logic shift to the right. Bit shift to the right 3 times. Which means we're dividing by 8 now. And now we're not transferring to X, now we're transferring that result to Y. So by doing this, the pixel position, X pixel position of the sprite, by dividing that by 8, now we're getting the column. So what column is he at now? So now we have found a row, and now we are finding the column. So just by doing that, now the column is in Y. The column is in Y now. So if I use my setup up here, like we've seen before, and with my Y, now I know exactly what character on the screen a sprite is at right now. Of course, we added some offsets here as well. But don't forget, this is just for one of those 3 checks. Spriting is moving up, but this is just for one of those 3 checks. So, for example, we're checking this top left corner, for example. So that was for 1 check. We need to do 3 of those checks when we're moving up. 3 of those checks moving right, 3 of those checks moving down, 3 of those checks moving left. So for every direction, we need to do 3 checks. Yeah. So, let's see. Yeah, here we are. So what I'm saying here, load A. So I want the screen code. So now, because you know that from CP row low, now we have created a memory address from the screen RAM, right? That's what we're reading from. We're reading from the screen memory at a certain position. That position was the position of the player. So now I'm gonna get back a screen code here when I'm doing this. But then I say sec sbc, subtract with carry. Now I'm subtracting 64. Why? Well, like we can see in the comment here, the first 64 chars are letters and numbers. So if you go back to char pad here, what I'm talking about are these 64. The first 64 chars in here, as you can see, they are letters and numbers. They are not going to be part of my background. So I'm going to start counting these characters, background characters, from, if you see down here, from character 64. That's the first one I'm going to count. Then we have 65, 66, 67, and so on. So, like I said before, this area that I started by making purple, this area is going to be the area for my characters, those that are going to be in my game here. So I divide by 60. I subtract by 64 because now this character is 64, right? But if I subtract these by 64, that means that instead of 64, this would be 0. It's actually 64 right now, but if I subtract with 64, that's going to make it 0. So basically my starting character. Let's put it that way. So this is my starting, so 0, 1, 2, 3, and so on. That would be the result of subtracting 64. Why? Why am I doing that? Well, let's take a look. I'm subtracting 64, then I say transfer A to Y. First, I'm loading that screen code that we had, and let's say it was this one. That's screen code 67. You can see it down here. Screen code 67, okay? So if I'm subtracting 64, then that means that I now have 3, number 3 in A. Transferring A to Y now, so now Y is 3. Then I say load A with a new table, char type table, comma Y. So now we need to look at a new table here. If I go to my project and I go to char type table here. Here I have something called char type table. And I've written a comment here that says check the char number in charpad to see what type you want the chars to be. So here I have written the actual char character number that we can see in charpad. So here, for example, 67, and I hold my mouse pointer over this one. That would be this one. Here I've said that I want that to be solid. So if we go back now to this thing, load A with char type table, comma Y. Remember, Y was 3 at this point. All right, load from that table with 3 in Y. Okay. So here's the start of the table. So 0, 1, 2, 3. All right. So now we get this byte. And when making tables like this, we can also specify constants in here. So if you want to write the number 1 in here, or if you have a constant that's number 1, that doesn't really matter, because the constants will just be numbers. But in order to make this more readable, I made these constants instead. So I have a little cheat sheet here at the top that says what number the different things are. Char solid, that's 1. But anyway, let's not get sidetracked here. So I'm loading 0, 1, 2, 3. I'm loading this from char type table because Y was 3, 0, 1, 2, 3. Okay, so I'm loading this now, fine. Then I get back here. Get char type, store that in char collision. All right. So I store that. Now the next thing says it's from another library called reaction library. Let's wait just a second before we look at that. But oh, I'm so sorry. If we go back to sprite, let's see here. Yeah, sprite library. Now we can load char collision. And if we compare this to char solid now, char solid, that was 1. So if we here at the sprite library comparing to that, then we say, and if it was 1, then we go to this solid collision thing that we saw just a moment ago. So that's basically the logic behind this. I do these 3 collision checks, and especially if it's a solid collision, then I need to do something important here, because I need to stop moving the sprite. And I have those sort of things in every direction. So I can stop the sprite from moving left, right, and so on. But what was that about reaction? Well, here in my character collision library, I do these things where I find out where the sprite is and get that correct character and so on. But before I return to the sprite routine, I have some reaction things here. So a new library, reaction library. Okay, fine, let's look at that. My reaction library. Now this is a library that I'm going to use for different kinds of reactions. But in our case right now, it would be something like, what's going to happen if a sprite hits the wall from the side? In this case, I'm only going to do reactions if we are colliding from the sides, not the top or bottom. One of the reasons is because this is going to be a platform game, so if I have an enemy who's walking back and forth, so if he's walking left, I want him to reverse direction if he hits a wall. And if he hits a wall on the other side, I want him to reverse direction again. Or maybe this was, I was shooting a gun and the bullet flew and hit the wall, then I would want that bullet to disappear, for example. If it was a bomb, I was throwing a bomb at the wall, then maybe I want to create a bomb animation, an explosion animation, and then make it go away. Whatever. The point is that it's nice to have this sort of way to react to what's going on in the game. But you can see here that happens here when we get when we check the sprite collision and we get what kind of character it was. We get some sort of char type from this table. We have a table here that's going to tell us what that was. And then we jump to the reaction library. So the reaction library, I have different kinds of reaction, like I said. Has something called edge reaction. That's actually going to be useful if I want my player to go from screen to screen. But in this case, I am not going to check that. I'm in the reaction library, but the subroutine I'm running is check char reaction. So in our reaction library, I have a subroutine called check char reaction. Alright, so what's going on in there? Transfer A to Y. Transfer A to Y. What was in A? Let's go back and check. Just before I ran that subroutine, I said store A in char collision. So what the char type that we got from our table, that's what's in A. I just stored it here. So I have some sort of character type in A now. So when we get here, that's what we're transferring to Y, that character type. Then I say load A with char type reaction. So another table, this time comma Y. Alright, so let's look at that table really quick now. Let's see, maybe it was here. Yeah, here we go. Char type reaction. So load a char type reaction comma Y, which is this table now. From this table comma Y, so from here I can find out, and again these are constants, right? React, no react, react hurt, react warp. These are just constants that I made. In reality, of course, they are numbers, like for example 0, or this could be number 3, whatever. But in order to make it more readable, I put constants in here instead. But the point is that we're reading from this table, and based on what kind of character collision that was,
So we need to keep track of a lot of things here, because this connects to this and this connects to that and so on. So we have several several things to keep track of here. But when we get to here and load from that reaction table, because there's some sort of number in here, load A, and then we say jump check reaction number. Alright, reaction number, and that's down here. So reaction 0. Now we just loaded A with some kind of reaction number. So when we get down here, that's what we're comparing against. Compare with 0. We don't need to write compare with 0, but to make it more readable, I put compare with 0 here. So load A, compare with 0. Is it reaction 0? Well, if it is, branch if equal, then we go here. And reaction 0, that's no reaction. So we just return from subroutine. We don't do anything. If it's not 0, then we jump reaction 1. Then we go down here. Alright, is it reaction 1? Well, if it is, then we go here. And here it says stop moving, but that only applies to left or right movement. Alright, so if this was, let's say I was shooting something, and I just, it was a game where I was shooting an arrow. I was shooting an arrow and it hit the wall, and when that arrow hit the wall, I just wanted it to stop moving. I didn't want to destroy it, I just wanted it to stop moving. Alright, then I could have used this technique. It says stop moving, but only left or right movement. So clear sprite direction left and right. But if it was not reaction 1, then we would get down here to reaction 2, and this would reverse the direction and so on. So the whole point here is that we have a system to handle a character collision. So we need to check what character we collided with, and we can do that by reading screen RAM. And now we know how we can find what characters we are colliding with, because we know we can divide the X and Y position of the sprite by 8. Maybe you would like to add some offset as well. But we can divide the position with 8. And then just by using our good old trick here, our tables, screen tables, then we can construct the actual memory address in screen RAM that we are colliding with. We can read that, find out what character it is, then we can have some sort of tables that will give meaning to us. So this character is going to mean that in my game. This is going to be so and so. So now you can see that we add the complexity that we want, the complexity that we are comfortable with. Now, as I said, this is starting to get a little complex. So you can see that, like I said last time, things are really starting to connect here. That's character collision and reaction. And this reaction thing also has to do, like I said, with edge reaction. So I just have one library for reactions because I have a set number of things that I would like to happen. Like, for example, well, no reaction, that's the default one, right? It's reaction 0. But then we have some stop moving. Well, maybe I would want them to stop moving, a sprite to stop moving if we hit the edge, not just a solid object. Maybe I wanted a sprite to reverse direction when something else happened, not just hitting a solid object, and so on. Go to the next screen, whatever. So I have, instead of writing these sort of things several times in many different libraries, I just collected all of those things here in the reaction library, and they just have a different way of entering this library. So for example, if you look at edge reaction here,
there's a table called sprite edge reaction. So in my sprite tables, there's this table with like all of my tables in there. It has 8 entries. So each sprite has their own sprite edge reaction. That's I trigger that when I reach the edge. So a solid reaction, that's triggered when there's a solid reaction, and so on. And we just looked at char reaction here. So there's a lot of stuff like that. Yeah. Let's not go more into detail about that. But I do want to show you something else. So now we have seen that we can stop a sprite or make basically anything happen when we collide with different characters. And we have looked a little bit at how we can make that happen. But this is a platform game. I want them to be able to jump and go down again. Well, like I said last time, this is not going to be some super advanced fancy game, because I'm sure you can see already that it's kind of complex already, and we don't need to add extra layers of complexity to this. So movement is going to be really basic, really simple, but it's going to work. That's the important part right now. So what I wanted to show you was we looked at movement, but since it's a platform game, I want to add some very, very simple gravity. So here I added something called, when sprite is moving up, I'm adding a very simple little jump thing here. So I have a few tables here. Sprite jump timer, sprite jump strength. And just like with that speed thing we saw earlier, we just define a certain number here in jump strength. That's going to be his jump strength, so how high he can jump. And there's just a little companion table that I call a timer here. So just to compare it to the max number which is in here. So if I'm moving a sprite up, that means it's jumping, so it's moving up, and when we have reached that number, then he has reached the maximum height of his jump. And if that happens, then we clear sprite direction up, so it's not gonna move up anymore. Now this jump mechanic, there are several things that we could have done, and many things we could have looked at. But in order to just make some jump thing happen, you can just do something fairly simple like this. So we're just talking about moving the sprite up to a certain position, and when he has reached that position, we need to make him go down again. But we also need to make some sort of things for, we don't want him to jump and in the middle of a jump he can jump again, because that would just mean that he's actually flying. So we don't want to do that. But the main thing that I was going to show you now, if we go down in this pretty big sprite library, sprite collision, we're not going to be looking at that right now, but here we go. Some very, very simple gravity. So if we can jump up, what's going to bring him down again? So if we move the sprite up in the Y position, and this is going to feel like some sort of gravity, then something has to move him in the other direction. So there's a little section here in this handle sprite subroutine that says, I have something for ignore gravity. Let's not look at that right now. But here we go. So remember, it's very simple jump physics, very, very simple gravity. But here we say check sprite direction up. Is it moving up? Branch if equal skip gravity. So in this case, I just said that if the sprite is moving up, then don't try to move him down, because that's going to collide because yeah, that's not gonna feel like a jump. It's gonna just stand like that. So if it's moving up, don't do any gravity. But if it's not moving up, then set sprite direction down. So this whole system is based on directions. So if I set sprite direction down, then it's just gonna move down. Skip sprite gravity. Here I just say clear sprite direction down. So we clear that direction and it won't be moving down anymore. So yeah, the gravity, I don't know if you can even call it gravity, because it's just a matter of moving a sprite up or down. But like I said, let's keep it simple here. So the point was to show you that if you want to make some sort of platform game, that we need to think about jumping and gravity. And I would recommend starting with something simple, because we're just talking about moving the sprites up or down on the screen. And once again, we need to give these sort of things meaning. So when I move the sprite up and stop him at a certain point, start moving him down again, that's going to mean jumping and gravity in this game. And the better we get the programming, the more smooth jumps we can make, and sort of things like that. So yeah, but the whole point here was to show you that now we're getting to a point where things are, like I said last time, starting to connect, and we have to think more and more about the environment, the things that we're interacting with, because now we're not just moving some sort of graphic anywhere on the screen. Now we say that you can't move further because there's a wall here, or when you're landing, you have some sort of gravity, you're landing and you're going to stop on top of this specific character. And we have also seen that when we are checking character collisions, because the sprite is so big, we need to check at multiple positions. Alright, well, let's just for fun, let's just try to run our little game now. Oh, I wrote something up there, so here we go. Now, like I said, this is the finished game. I say finished game, but the finished test game for this course. So here everything is in place. Here we have our start screen, and here we go. So now you can see we have, maybe we should turn off the music just for now. So I'm gonna disable music, there we go. Alright, anyway, so here you can see that I'm moving the sprite on the screen, but he has certain rules, right? I jump and I let go and he's pulled down. I move left. Now there's animation here as well, but we're gonna look at that later. So when I jump and I can land on a branch like this, then he stops moving down. But this is sort of those jump through platforms I was talking about. So I can jump from below and land on the top. And here we have a brick wall, and I can't move further when I hit a brick wall like that. And now I'm just gonna hold up on my joystick. So even though I'm holding up, he's just jumping to a certain point, and then he starts moving down. So when we start to combine everything that we have learned, then we can start making things like this. Now, as I said, keeping in mind that we haven't looked at animations yet. But hopefully you can see how these things are connected and how things are working together. Joystick input, sprite graphics, and now some sort of collision routines as well. So I think I'm going to hold back a little bit giving you all this code, because there are actually not that many episodes left. I think we have like 5 or 6 episodes left. So by the end, you'll get this whole thing. But for now, I just wanted to show you that by combining everything that we have learned so far, we can start. I'm sorry, we can start making a game. Okay, so I think that's enough for now. Now I have to apologize for clearing my throat all the time. I have a few health issues, so I'm sorry about that. But anyway, now we've seen a character collision and how that works together with sprite movement and stuff like that. So I don't think we should go any further into the details right now, but hopefully you could see what was going on with the collision routines. Alright, well that's enough for now, so I'll see you next time. Bye bye.